Yep. So welcome back. We continue from where we ended. Okay. So we get the full background image, and we have the CV2 function that allows us to do that. So we allow them like this one. Okay. So this creates the background, like the person creating a variable that will take the background subtractor. Okay. Then what we do is that we take this background subtractor and apply it to the gray image. So when we come here, we say, okay, let's form a new image. Call this a background image. So this is a new image for a background image. What we're going to do is that we're going to take the subtractor, which is this, which has how's it called? Function apply. We apply this to our gray image. Okay, apply this to our gray image. Then over here, instead of showing the gray image, let's show the background. Let's see, let's show the background image. And let's see what we have over here. So I'll go ahead and run this. And you see. Okay. So we could see that some parts are white. And others also black. And there are some noise in there. And we could see that the part that are black are mostly the static places. And you see the white things are the moving objects. So as I said, when separating in between frames, the places that are static will have the same values. And when you do the subtraction, it's going to give you 0. The places that are moving are going to have change in values. And as such, we can show those values, right? But this is not good enough for our work because there's a lot of noise. So we want to do some pre-processing to reduce the noise that we have in the set. Yeah. So we come to this function, our background subtractor. It takes certain inputs such as the history. So like the number of frames that he has to look, history of frames he has to consider doing the background. We have let's start with 50, right? So 50. Then the threshold, like it has a variance threshold that is going to use. The variance threshold, we can start with let's say 45. You play around with this threshold to see whether you're getting a better image or not. Then you realize that when we are showing, let me do this and run this and see something. But we could see that there are some gray image, gray stuff beneath the vehicle. Very gray. So those are the shadows of the vehicle. Now we could see that we have reduction in noise, even by introducing the thresholds. Okay. So function that allows us to take off the shadows. Yes, detecting the shadows. So over here, we will pass in false. Okay, meaning we don't want to detect the shadows. So we can run this and see the shadows. Okay. So now you can see we don't see the gray things beneath the vehicles again. Okay. We still have a couple of noise in there. Let's try to play with the threshold so we get better results. So let's use H250 at 100 frames. Let's change our threshold to let's say 100. Let's try and see whether this is better. Okay, this looks okay, not bad. We have less noise, so we realize that the white things, the only white things we see are the vehicles, and almost everything is black because everything becomes a background. There's no movement, and the only thing that is moving are the vehicles. Okay, as showing the white. So when it does, it just maximize it and give it 255 if there's any value there, and 255, and that makes it white. And if it's not, it is 0. So when the subtraction is done and there's a movement, values automatically set to 2 to 5. 5, 5. Keep saying 2 to 5. So that works. So normally, people also apply the Gaussian blur to remove Gaussian blur to remove, let's say, noise from the data set. Using this, might not need to do Gaussian blur and stuff. Okay. So we can move on from here. Now, let me show the video once more. Now, there's a function that allows us to get the contours of these moving object. Okay. Okay, so like if there's nothing, you're gonna have like 0, 0, 0, and this is a contour. You can see the change in threshold, like the change in pixel values. Okay, so you're gonna use a CV2 function to find the contours. Okay. So we'll come here. I will say CV2 dot find contours. So see what it does. It takes in the image, the mode, the method, the contours, right? So here I'll do this, find contours, and I'll pass in my background image. This is this. And for the, what do you CV2? CV2 dots. I like using this one. Method. Then okay, CV2 dots. Yep. That should be fine. Okay. And this function returns two things. It returns the contours and the hierarchy. Okay. Um, we don't need a hierarchy for anything. All that we need is a contours. So variable for contours. Then the other thing we don't need, okay, the hierarchy. We don't need the hierarchy. Okay. I mean, you can put it here, but we don't need the hierarchy. So you can create a variable called hierarchy and put it instead of the underscore. Okay. But I normally put the underscore there because I don't need the hierarchy. All that we need is a contour. Okay. So now what we do from here is to look through the contour. Okay, is to look through the contour and try to get the boundaries of the contour. Okay. So let's see. Um, Let me print the contour. Print contour. Print CNT is. Let's see. Let me run this and let's watch. Let me comment this and show this. Then let me run this. Now you can look at it. So you could see that it's giving us some sort of information um, that we can derive. Okay, that's what we used to draw our rectangles. Okay, good. Okay, so, okay. So let me start the code. Okay, start the code. Okay. The next thing is to do is to look through the contours. So I'll say for contour or for cons in contours. Okay, for the contours, I want to get some parameters, right? I want to get X, Y, U and H, right? So is a XY is the first coordinate. That's the upper left coordinate. Then the width and height, okay, of the image, of the, sorry, of the contour. Okay. So CV2 dots bounding red, okay. So pass the contour through this, it gives us this values, this degenerated values, which is the XY coordinates, that's the upper left coordinates, and the width and height of the contour boxes. Then see and see. So for each contour that we read from the contours, we want to get this. And once we get this, we learned about plotting rectangles, right, on images, and we use a CV2 dot rectangle to do that. So we're going to do the same thing, okay? So I now have an image here. That's okay. It's equal to CV2 dot rectangle, okay? And we say it takes in the image, okay? It takes in the image, and we pass in the first point, the second point, the color, and the thickness, okay? So the image we're going to pass in here will be our colored image, so that we can draw our boxes on a colored image, okay? So we pass on our colored image, that'll be this. It's a colored image. Then we pass in the first point. The first point is going to be XY, okay? That'll be the first point, it's going to be XY. That's the upper left, okay? And to get, that's the first point. Now to get a second point, that's the bottom right coordinate. We need to add the width of the contour to the X coordinates and the height of the contour to the Y coordinates. Okay, so you're going to have a new coordinate, something like X plus the width, comma, Y plus the height. Okay, so this will give us the bottom right coordinates. Okay, that's what we need. We need the top left coordinates and the bottom right coordinates to draw the bounding box. Then the next thing we need is the color, and this we use this. Okay, and this is blue. And the thickness is a 2. Okay, then we can show um, our image. So here, let me scroll down. Let me uncomment this. Push this under this good. Then over here, I'll show this image that I've created now. I'll show this image I've created now. So around this. Okay, so you can see it's drawing bounding boxes around it. And like there's some small boxes in there, and it's due to the noise and all that, because like as you get a contour, it draws it around. So we can set a threshold that, hey, some boxes have very small area, okay? So we can set a threshold to eliminate some of those small bounding boxes by giving it a certain threshold for area, okay? We're gonna do that. So we'll come here and we will give a certain if condition, okay? So we'll find the area when we get the bounding boxes, make the contours, use CV2 dot contour area, which is this, to get the area of the contour, okay? Then we'll set an if function that, hey, if a conditional statement, so if the area is greater than a certain number, then continue. Else, we don't need it, okay? So we say that if the area is greater than, let's say 500, okay? This will be the best choice. Um, then do this, okay? Do the area. So let me do this over here, okay? So then if the area is greater than 500, then go ahead and get the XY coordinate as well as the width and height and continue with this and show us the image, okay? Let's see what we have here. So we can run this and see where threshold in the area. Okay, so you could see that we have been able to remove um, the small boxes in there, and we have a very good object detection. So in this, we have been able to, to detect moving objects in the video. Um, and we could see there are still some problems because vehicles are very close together. They cross one bounding box around them. That's some sort of occlusion. So um, these are issues that we try to solve using like deep learning techniques, convolutional neural networks, um, to solve such issues. Um, so this basically we are trying to detect objects, moving objects in the background, and to do object identification. Um, then you move to like more of like deep learning where we feed labeled information to convolutional neural network to learn characteristic of different vehicles and identify that, hey, this is a car or this is a truck and all that. So here you've been able to do some object identification um, from moving object. And the next thing we'll be doing is, hey, how to track each object. Okay, so now we have the object being identified, but we should be able to track them. Say, hey, this object moving in frame one is the same object moving throughout. So that'll be it for this. And we'll continue next time. Bye.